This is the last example for solving for the basis of the range and rank of a linear transformation involving a matrix. We have here a 4 by 4 matrix, and for this we have 4 columns, and we're going to identify which of these 4 columns are part of the column space of our A, which is equivalent or equal to the basis of the range of a transformation T. That would mean we're going to come up with its reduced row echelon form, because the column space can only be determined once we know which columns contain leading ones after we have transformed a given matrix into its equivalent reduced row echelon form. Since our first entry here is already 1, that should be its leading one. Hence, we'll make 3, -4, and -1 equal to 0 by this process. First, multiply -3 to row 1 plus row 2 to get another row 2 or a new row 2. Then multiply 4 to row 1 plus row 3 for row 3, and then simply add row 1 and row 4 for your new row 4. We have here 1, 2, -1, and 4. And then what happens here is this. -3 times 1 is -3 plus 3, 0. -3 times 2 is -6 plus 1, -5. -3 times -1 is 3 times, plus 2, you will have here +5. -3 times 4 is -12 plus -1 is -13. Next, for the third row, 4 times 1 is 4 plus -4 is 0. 4 times 2 is 8 plus -3, you have +5. 4 times -1 is -4 plus -1 is -5. Then 4 times 4 is 16 plus -3 is positive. That's +13. And for our fourth row, simply add them. 1 plus -1, that's 0. 2 plus -2, that's 0. -1 plus 1, 0. 4 plus 1 is 5. From here, we could see 2 rows which are multiples of the other. This is already a hint that we are expecting to have a row of zeros in our final form of the reduced row echelon form. So what we need to do here is next, we can divide this by -1/5 so that it would become a leading one. So you'll have here times row 2 plus, times row 2 only. Okay. For a new row 2. We have here 1, 2, -1, 4. This is 0. This is +1. This is -1. This is +13/5. This is still 0. 5, -5. You have +13. 0, 0, 0, and then 5. Next, let's make this 0. Okay. By multiplying -5 to row 2 plus row 3. Okay. So you'll have here 1, 2, -1, 4. 0, 1, -1, 13/5. So -5 times 1 is -5 plus 5, 0. -5 times -1 is +5 plus -5, 0. -5 times 13/5, that's -1 times 13, is -13 plus 13, 0. See, we have a row of 0. The last row will still be something like this. Next is to interchange row 3 in row 4, because the row of 0 should be at the bottom portion. 1, -1, 1, 2, -1, 4, 0, 1, -1, 13/5, 0, 0, 0, 5, 0, 0, 0, and 0. Okay. Next here is to make this a leading one, so we can divide or multiply 1/5 to our row 3. Okay. 1, 2, -1, 4, 0, 1, -1, 13/5, 0, 0, 0, 1, 0, 0, 0, 0. This is not yet the reduced row echelon form. This is just the row echelon form, because for this to become a reduced row echelon form, all entries on the same column having leading 1, I'm talking about 13 fifths, 4, and this, they all need to become zeros. No need to touch this because that's not part of our pivot column, or nor it doesn't have leading 1. So what we could do here is for this and this first. So negative 13 fifths, sorry, 13 fifths of row, my bad, fifths of row 3 plus row 2 for a new row 2, and negative 4 of row 3 plus row 1 for a new row 1. You have here 0, 0, 0, 0, 0, 0, 0, 1, then 0, 1, negative 1. So negative 13 fifths times 1 is negative 13 fifths plus 13 fifths, that's 0. Next, 4, negative 4. This is still 1, 2, negative 1. Negative 4 times 1 is negative 4 plus 4, 0. Then, finally, this one here, we can multiply negative 2 to row 2 plus row 1 for a new row 1. So you have 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, sorry, 0, 1, negative 1, 0, and here comes the result. Negative 2 times 1 is negative 2 plus 2, 0. Negative 2 times negative 1 is 2. Plus negative 1, you will have 1. And this is still 0 here. Okay, so noticeably here, the first column, the second column, and the fourth column contains leading 1s, and these are the pivot columns. Okay, we don't consider this leading 1 because we already have a 1 here. So only column 1, column 2, and column 4 are the pivot columns, and they must be part of the basis of range. So the basis for the range of T is a set containing the row 1 of the initial matrix 1, 3, negative 4, negative 1. Next, the second row, you will have 2, 1, negative 3, negative 2. And finally, the fourth column, 4, negative 1, negative 3, and then 1. Or you could have it in this form: 1, 3, negative 4, negative 1, 2, 1, negative 3, negative 2, and 4, negative 1, negative 3, and then 1. Okay. This is now the basis for a range. And then the rank of T is actually equal to the dimension of the basis of your range. The dimension of the base of the range is actually the number of elements that can be found on the basis of the range. And we have 1, 2, 3 vectors. So the rank of T is equal to 3. So this ends the discussion for the basis of the range and the rank of a linear transformation involving matrices. Again, the goal here is to come up with a reduced row echelon form. Pick those columns with leading 1 or considered as pivot columns. They are the elements of the basis of the range. And the rank of T counts the elements of the basis of the range. Thank you very much for watching.